Hey, chemistry. So now we're going to focus on alloys, which are mixtures of different metals that can give the metals the properties that you need for different uses. So a alloy is defined as a mixture of two or more metals or metalloids that can obtain desired properties. So some examples of alloys include brass, which is the combination of copper and zinc. One advantage of brass is that it has a golden color, so it's a lot cheaper method to create that golden color than actually having gold. Bronze was one of the first alloys ever used, and that is the combination of copper and tin. Bronze gives kind of that deeper color of kind of a goldish to brownish color, and bronze was used in the Bronze Age to make weapons and armor and things like that. Steel is an alloy of iron, so it's primarily iron, but by adding certain other elements to it, like manganese or carbon, you can strengthen that iron and give it more strength and less malleability. So it's better for making structures that are made of metal that you don't want it to bend under the weight. Other alloys can also have higher melting points or provide rust protection. Even gold is often alloyed. If instead of using pure gold, which is extremely soft and can be damaged, you may want your jewelry or other equipment to be a little more structurally rigid so it's not easily bent or dented. And so you can add other metals to it like silver or nickel or palladium to create alloys of gold. Another value with an alloy of gold is that you can reduce the gold content and make it cheaper. And so the K for carat is a representation of how much gold it is. The higher the number, the more pure gold it is. So 24 karat gold is basically pure gold, and then as you go down from there, that makes it less and less. So there's a few different ways that you can insert atoms into an alloy to give it the structures that you want. So one way is what's known as a substitutional alloy, in which you replace the metal that was there with the atoms of a different metal, and they go in the exact same location. It's simply a different metal that's going in that location of the crystal. Substitution alloys would include things like adding silver atoms instead of gold atoms when you're making your alloy of gold. There's another one called interstitial, where you actually insert the atoms of the different elements in the spaces between the crystal and structure of the original metal. And those often give the metal a lot more rigidity and strength because the atoms are not able to slide as easily. It reduces its malleability. So substitutional or interstitial. There's a video that is about alloys that actually shows the making of alloys and where those atoms are located. So I'd like you to check out that video. So probably the most important alloy on Earth is alloys of iron, steel, because we use steel to build everything, to provide structure to buildings and pipes and cars, and just about everything, it seems, is made of steel. Iron is a great metal because it is abundant and cheap, but it has some drawbacks, especially it's sometimes not the strongest metal. It can bend fairly easily, and it can rust. And so we want to create a substance that is going to be stronger and less rust likely. So we can add metals like manganese or titanium, molybdenum or vanadium, and we can insert them into the metallic structure of the iron to give it the properties that we want. In fact, there's a whole field of science known as material science engineering. And it is an incredibly important and fast-growing field. If you want to get a good job that's high-paying, go into the science of the material science engineering, because it is the study of making things that have the properties that you want by exchanging and moving atoms around and creating new structures to give us the properties that we want. We want things that are lighter. As we're trying to build cars that are more fuel efficient or airplanes that are more fuel efficient, we need them to be lighter. So we need to have metals that have the properties we need of strength and rigidity, but much lighter. We need things that are more tarnish or rust resistant. We need things that are either more malleable or more rigid. So material science engineering is that study of making things with the properties you want. So here's an example of an alloy that has the property we want, which is stainless steel. So by adding chromium to steel, we're able to make a metal alloy that resists corrosion. You'll notice in this picture that there are these rusty bars in this kind of steel heap here, and those don't contain this sort of corrosion inhibited property. But all the others remain silvery and shiny even after years of exposure to the environment. And the reason is that when stainless steel is exposed to air, the chromium that's mixed in reacts with oxygen in the air to form a protective layer called chromium oxide. That chromium oxide blocks oxygen from reaching the iron underneath and prevents the iron from rusting. So you can say that stainless steel is self-healing, because essentially what happens is that this chromium oxide layer forms this protective barrier. If you damage the steel, let's say you get a cut into it or a dent into it and you damage and remove that chromium oxide layer, the chromium atoms that are embedded throughout the metal are able to then repair and reform that protective layer. So stainless steel essentially never rusts even when damaged.